This video is designed to help you with the idea of finding area and perimeter of some more complicated shapes. These will be symmetric shapes, but you don't need to really worry about that definition, only to know that if something looks like it's the same, in other words, this one looks like two equal sized triangles, then that is the case. We can formalize some of that in another video later. But the idea here is to find both the area and perimeter of three different symmetric figures that I will present. In this first slide, we have a butterfly shape. And to find the area, you need to find shapes that you have formulas for or that you can combine formulas for. So there are several ways to approach this one. The easiest way is to imagine that you have two triangles which have a base of 12 and a height of 7, and that height of 7 is because the whole thing can be split into the two pieces, and it would be 7 on the left side and 7 on the right side. And if you turn that triangle 90 degrees, you realize it can sit on the base of 12 and have a height of 7. So to find that area of the shaded region, area subshaded, it's 2 times the area of this triangle that I've drawn, which of course is then 2 times 1/2 times the base times the height, which is 7. So if you sort this out as cleanly as possible, you can see that the 2 and the 1/2 will cancel because the parentheses were just there for effect, but it's a bunch of things multiplied by each other, so it can be done in any order. And of course that means that our area is 7 times 12, which is 84, and so this gives us an area of 84 units squared. So to find the perimeter, there are other ways to find the area. You could break it into smaller triangles, and each of those triangles would have a base of 6 and a height of 7, or a base of 7 and a height of 6. Now notice, of course, that the length of 7 is along here. Those slanted sides are not 7 long. We'd need to use the Pythagorean theorem to find those, and you couldn't use those as the base because this area in here, those are not right angles, or not necessarily right angles. As it turns out, they're not in this case. So in order to find the perimeter, we need to be the ant, as the expression goes, and that means to start somewhere on this shape, preferably at a vertex. So we'll start up here and then be the ant and simply walk around this shape and then try to imagine how far we walked. So that first section that we walked 12 units. The second section that we walked, that's a slanted side. We're going to just call that X for now. And so we're going to walk X. Then of course we're going to walk X again. So that's another X that we're going to add. And then we're going to continue walking up this side. Dum-ta-dum-ta-dum. There goes the ant. And of course that's another 12. Continue being the ant. Walk down. You're going to walk X again because all those sides are the same. This is a symmetric shape. So this is X. This is X, and the last side that we're going to walk as the ant is once again X. And therefore, what we have is 12 plus 12 plus 4 X's. So what we need to do is find a way to figure out what X is. Now, that's going to ask us to create a right triangle so that we can find the length of one of those slanted sides. Now remember, the original triangle that we drew that had a base of 12 and a height of 7, if it has a height of 7, it's a right angle here, and we can imagine that this triangle is that shape. I'm going to reproduce that off to the side. and then it has a base of 6, a height of 7, and we can find x by using the Pythagorean theorem. So that means we're going to use 7 squared plus 6 squared equals x squared. And if we solve this, we're going to see that x squared is 49 plus 36, which is 85, which means that x is going to wind up being the square root of 85. So x is the square root of 85, which is approximately 9.22 or so. So that means that our perimeter then simply is 2 12s, so that's 24, plus 4 x's, or 4 times 9.22. And if we total all this up, we're going to get approximately 60.88 units. And that's how you would find this guy's perimeter. This next figure is also a symmetric figure, and we now have, of course, in some ways a more challenging look at it because we have some curved edges. So what we need to do is imagine for the area that we can put this thing together, the area of the shaded region, we can imagine that it's 2 complete circles, so it's going to be twice the area of one of the circles. Now, how do we find the area of a circle? Well, the area of a circle is pi r squared. So we have 2 times pi r squared, r being 5, as you can see from this drawing. So we have 2 times pi times 5 squared, which we can again multiply out in any order, and that's going to be 2 times 25 pi, or 50 pi, units squared. Now, of course, if you want to multiply that out, you can get an approximate answer, and that approximate answer would be roughly 157.08 units squared. So that wasn't so bad, as long as we can imagine that we can move the half circles around, combining them to make whole circles. Now, that works fine for area. You don't lose or gain area when you cut pieces up and move them around and shift them around. You still have the same amount of shaded area. However, you can't do this to the perimeter. So for the perimeter, once again, you need to imagine being the ant, and you need to start somewhere on this figure, let's say right here, and start walking around. So, how far did we walk when we walked there? Well, that is 1/2 the circumference of the circle. Continue on as the ant. Oh, by the way, we have to walk the base of a circle, or the diameter of it, in that direction. So that's going to be plus a diameter. And then, of course, we continue around in this fashion, and we notice that we walk another half circumference, another diameter, another half circumference, another diameter, another half circumference, and another diameter. So if you just simply follow the ant's path around this, you're going to get this total coming out, where you have half a circumference, a diameter, another half circumference, a diameter, another half circumference, another diameter, another half circumference, and another diameter. So of course you could view this as 4 half circumferences, which is of course 2 complete circumferences, and 4 diameters. Now, the diameter is fairly easy because we know the radius is 5. So the diameter is 10, which means that we can plug in 10 right here and get 4 times 10 for the diameter. But the circumference of the circle we still have to figure out. So we go off to the side again, and we say that the circumference of a circle is 2 pi r. Since r is 5, that means the circumference is 10 pi, because it's 2 times 5 times pi. So what we have is a circumference of 10 pi, which means when we plug into our formula, what we're going to get is 2 times 10 pi plus 40, which means that our answer is 20 pi plus 40 units. Now, of course, if we want to figure out what that is, we have to be careful not to say 60 pi, because we have 20 pi, but we have 40 ones. What that means is we have to, if we want to collect this and turn it into one answer, we have to get an answer for what 20 pi is, and that is going to be 20 times 3.14 or 20 times pi, depending on how accurately you want to keep it. So 20 times pi is about 62.83 added to 40, so this is 62.83 or so, plus 40, which means our approximate answer is 102.83 units. Finally, we have our third figure, which it looks even more complicated, but if you follow the same ideas, we can take the bottom half and slide it underneath the top half, and we're going to get a circle with a hole cut out of it, which means that the area of our figure, of the shaded region, can be found by finding the area of the big circle and subtracting the area of the missing part, which is the small circle. And that means we need to identify the radiuses of those circles in order to find the areas. And the area of the big circle then, since it's 6 from here to here, 6 all the way across, that's the diameter of the big circle, which means its radius is 3. So R big is 3, and that allows us to write that we're finding the area of the big circle by doing pi times 3 squared. And the area of the small circle then, since the diameter of the small circle is 1, we get to subtract, we get to subtract the area of the small circle, which is then going to be pi times 1 squared. Now 1 squared, of course, is just 1, and 3 squared is 9. So this gets us 9 pi minus 1 pi, or 8 pi units squared, which we could multiply out if we wanted to get an approximate answer of 8 times pi, which is about 25.13 units squared. Not too bad. Remember, what we used as our main approach for this is that we slid the bottom half under the top half and said, oh, what we have is a complete big circle and a cutout missing portion of it in the center. So oftentimes the area of a shaded region can be found by finding the area of an entire region and subtracting out the part that's missing. That may be easier than doing some other process, because what we're looking for is things that we have formulas for so that we can make this problem easy. As far as the perimeter, we simply have to be the ant again and walk around this shape. So I'm going to start at this corner right here and start walking. So if I'm the ant, what have I just walked? I've walked 2 units. I continue to be the ant. What have I just walked? I have walked the circumference of half of the small circle. So that means it's going to be plus 1/2 circumference of the small circle. I'm going to continue to be the ant, walk another section, and I have a way of figuring out what that other section is. That's the circumference, half the circumference rather, of the big circle. Continue to be the ant. I'm going to walk 2 again. So that means I add 2. once again, continue to be the ant. Obviously, I've walked another half circumference of a small circle. And finally, I walked the last section as the ant, and I walked this whole distance there, and I have walked half the circumference of the big circle. Once again, we need to know our formulas, but we can also put these together and say, look, we have two 2's, that's 4, and we have half a small circle and another half circumference of a small circle, so we're going to be adding a whole small circle circumference, because half of one and another half of one gives us a whole. And we can do this one more time and recognize, so the two small ones combine together, and then of course we can take the two big ones and put them together and get a whole circumference of the big circle. Circumference, again, as a reminder, is 2 pi r, and we have to go back and remember that the big radius is 3, and the small radius, and I'll remind you up above, r sub s is 1. So the radius of the big guy is 3, and the radius of the small guy is 1, because its diameter is 2. So what that means is that our perimeter then is equal to 4 plus the circumference of the small circle then is 2 times pi times 1, which is just 2 pi, and the circumference of the big circle is 3 times pi times 2 times pi times 3, which of course is going to be 6 pi. So that means that we have a total perimeter of 4 plus 8 pi units. And of course, we can multiply this out and figure out what 8 pi is, 25.13 or so. So that gives us 4 approximately plus 25.13, or a total approximate answer of 13 units.